number 72 with or without replacement.
Mm-hmm.
All right, with or without, an important thing to understand. So these are about dealing cards.
Yes.
All right, so first thing, I didn't say hi, Mr. Lewis.
Hi, Mr. Miller.
All right, now let's get on with it. So the first side we have are 4 examples of with replacement. So you're going to be dealt 2 cards, and with replacement. That means after the first card is dealt, you put it back in the deck and shuffle, and then you deal a second card.
Right.
So these are independent.
Right. So there's always going to be 52 cards in the deck.
Okay, this is kind of like our last quiz on the stretch. So we've been here and done that. But let's review. So the first one is probability of getting 2 hearts.
Well, there's a 1/4 chance of getting a heart, and then a 1/4 chance of getting another heart. So multiply that together, and it'd be 1/16.
Okay, and again, this is the third probability law for intersection. The first one is a heart, and the second one is a heart. And since they're independent, we multiply the probabilities.
Right.
Okay, second one, no hearts.
Well, it'd be 3/4.
That's the first one's not a heart.
And 3/4.
Second one's not a heart.
So 9/16.
I kind of like with replacement. Makes it easy.
Yes.
All right, 1 heart. We got to think about this. There are 2 ways that could happen.
Right. I could get a heart and then not get a heart.
Okay.
Or I could not have a heart and then get a heart.
Yeah, so 2 ways it can happen. Hearts on the first one or the hearts on the second one. So both have probably 3/16.
Mm-hmm.
And when you add those,
We would get
6/16.
16ths.
Okay, so sometimes we have to be in mind there's more than one way it can happen sometimes.
And now we've gone through all the hearts, so another way to do it would know that this and this and this would all have to add up to 100%.
True. Because we're dealing 2 cards, and the possibilities are 0, 1, or 2 hearts.
Right.
All right, next one, 2 face cards. So probably the first one's a face card.
Is 12 out of 52, 3
out of 13.
Yeah.
And then the second one.
3 out of 13.
Right. So the second card comes from like a identical situation.
This would be 9/169.
Cool. 1 ace. Here we go. There are 2 possibilities.
Right.
So let's do the first card's an ace.
So 1 out of 13.
Times probably the second one is not.
Which would be 12 out of 13.
And then
the easy way to do this would be
times 2.
Right. 12 out of 169. And then, yeah, just multiply that by 2, because there's 2 ways of getting that. And then what would be 24 over 169. Boom.
Cool. Now, let's switch to without replacement. So the deck changes. And this is actually a conditional probability. So if you're dealt 2 kings, you got to think, probably the first card is a king times the probability the second card is a king, given that the first one was a king. So this is still the third law of probability, but it's the case when they're not independent. All right, so probably the first one is a king is 1 out of 13. But now the deck has changed, so this is times. There's only 51 cards in the deck now.
Yes.
So, and one of the kings is gone. So
Right.
only 3 kings. Reminds me of a song.
Yes.
So that would be 3 over 51 times 13 is 663.
663.
It's not going to happen too often.
No.
All right,
It's not.
next one. 1 heart and 1 spade.
All right, well, heart would be 1/4.
Right? Now, and again, 1 card is gone, so we only have 51 cards now.
Right, so that would be 13 out of 51.
Because there are 13
cards.
spades. And so that'd be 13
13
over 4 times 51.
204.
Yeah, but we're not done yet. Because you could get 1. We didn't say what order.
That's true. So we'd have to multiply it by 2.
Right. Because you could get the spade first and then the heart.
26 out of 204.
Correct. 2 ways this can happen. All right, no aces. Okay,
Aces.
first card's not an ace. That's probably 12 out of 13. But again, 1 card is gone.
So now it would be 40. 47 out of 51.
Right. Originally, there are 48 cards that are not
Right.
aces, and one of them's gone, so there's 47 out of 51. All right, so the numerator is going to be 12 times 42, which is 504
4.
over 663. So you just got to think, that second card, you got to think the deck has changed.
Yes.
You got to think how many cards are left and how many of what you want is left. All right, 2 face cards. So initially,
To get a face card,
it's
it'd be
12 out of
3 out of 13.
3 out of 13 or 12 out of 52
Okay.
times. So 1 face card is gone.
Right.
So we have 11 left,
11 out of
51.
51.
So that's going to be 33 over 663.
663.
Okay, 2 black cards. That means they're a club or a spade. So probably the first one is a half. Half a black card, half a red. And then now we got to think. There's only 51 cards left. I like filling in that part first.
Oops. I don't know why I'm doing it.
And there's
Now there's
originally
only
26, so there's only 25 left. So that's 25 over 102.
102.
Okay. All right.
Done?
Yep.
Okay.
So we got one more example. So this is kind of analyzing a game, coming up with a probability model for the game.
Mm-hmm.
So 2 cards are dealt without replacement. If you draw 2 face cards, you win $20. 1 face card, you win 10. Everything else, you lose $1. So start by making the table. And the top row is
X and then
P of X. So you could win $20.
So $20.
The next thing is $10.
And then -1.
-1. Okay.
So
The way you win $20 is 2 face cards. So it's going to be
right.
3 out of 13
3 out of 13.
times. There's 11 face cards left, so 11 out of 51. We did this already.
We did.
So
We
this
probably
would
should
be
remember the answer.
3 over, wasn't it 663?
Yes. No, 33 over 663.
Yeah, I'm sorry.
Okay.
Wow, this is complicated. The next easiest one to get is losing $1.
Right.
So you lose $1 by getting no face cards.
Right. So that would be 10 out of 13. Wow.
10 out of 13.
And then, so subtraction is 47. I don't know why I put equals times. Out of 51?
Wait, where did the 47 come from?
Oh, God, because I'm terrible at math. 52 would be 39. Right.
So originally there are 40 cards that are not face cards.
Right. And I took one away.
So now it's 39
Now
out
it's
of
39.
51.
Man.
Wow.
Okay.
So
That took a
10
while.
times 39 is 390.
Okay. Well, this one's 663, and then top one's 390.
Yeah. So now we can just subtract from 1. So 663 minus 33 minus 390 is 240 out of 663.
240.
Wow. This is crazy. This takes a little practice at it.
Yeah.
But we can do this. We can think through the possibilities. That was
Yeah.
quick. So let's find the expected value. So I got to quickly enter this
Okay, so 33.
into list 1 and list 2. So we're not going to do this by hand. We're just
Oh.
going to use the TI-84.
Well, okay, then.
So I'm going to enter 20,
Never mind that.
10, and -1, and then the ugly probability. So 33 divided by 663. All right, the calculator can handle this. And then the next one was 240 divided by 663. And the last one was 390 divided by 663. Okay, so I'm going to stat, calc, 1 variable stats. List 1, list 2, calculate. Wow. We get the expected winnings is $4
Okay.
and 3 cents. 4.03. This is a good game to play.
0.03.
Yeah. So on average, you're going to win $4 a shot.
Yeah, it's not bad.
And then the standard deviation is 6.36. So there's our measure of center and spread. Theoretical values. So if we did this many times, on average we're going to win $4, and that's the standard deviation of our win. queens.
All right.
Wow, we flew through that. That looks so messed, but that's good math there.
Yeah.
All right.
Now it's their turn.
Yep. So, given a very similar game, if you draw 2 queens, this is without replacement. If you draw 2 queens, you win 50. 1 queen, you win 10. Everything else, you lose 2. So create a probability model for this game.
And then
Follow our example very closely, I think. You should
Mhm.
be okay. Then use your calculator to find expected winnings and standard deviation.
Right.